Good afternoon, everybody, and I welcome you all for this continued session on Internet of Things. So in this particular session, we'll be talking one very important and very familiar aspect of any network-based system. This is called security and privacy. As we already know that Internet of Things is a new world of connected objects. The connectivity goes beyond connecting people. It goes connecting to all the objects which are called smart objects. Okay. And in this session, we actually take on from where we have left in the earlier sessions. In the first session, we gave a very general introduction to IoT. And in the following second session, we talked about an architecture, a web-based architecture for Internet of Things. Now that we have established a network of things, then the obvious question would be like, will it be secure enough? Because any system which needs to connect it on a world over on a global level, and if you want to expect people to participate in that, you have to assure them two things. One is their privacy, that means what happens to their data when they are put it on the network, and how do they protect their assets, including data on the network. And this is what is going to be considered in this particular session. So the title of the session is, will IoT be secure enough? So if you have a question in your mind, if Internet of Things is secure enough to conduct my businesses or put my data onto that, conduct my business communication, the session will answer such questions. It will do that after considering all the different issues. And we all know that privacy and security are major challenges in building any IoT system or any network. For example, even today we talk about our data security and communication security in the internet. Similarly, when you are building an ecosystem in which things are connected, it's natural for us to consider about privacy and security. Privacy is all about actually what will happen to my data when it's on the network. For example, if I share my personal medical information, is it that only doctor sees that information, or even a medical shop person will see it? Okay, that is all about privacy. And security is that suppose I place my information on the network, will my competitor will see that, or will it be leaked to a third party who is actually spying on me? So these are the questions which are related to security. And normally, whenever a new system comes, one of the blocks or one of the barriers before the adoption is actually security and privacy. So whenever actually you start a new schemes, for example, in the 1970s and all, when banks started starting bank locker systems, people were worried about their money in the bank. How do I trust a manager in the bank? How do I trust a security guard in that, because I put my money and jewelry in that? But over a period of time, people are settled. So such concerns are very natural, and IoT is not an exception. So unless we solve this problem of privacy and security, people will not come onto that. Business will not come to IoT to do their business. People will not start using smart devices. So that is what the whole issue in this particular session. So I have a very brief agenda today. Today I will describe you IoT world. That means what does this IoT consist of? So once I describe that world, then I will develop an architecture which will ask certain questions related security architecture. That means how do I build an architecture for this kind of a world? So in the first one, I will describe the layers in which, that means like in internet there are 7 layers, OSI layers. There are certain layers in this architecture that I will describe you. Then I will help you to identify the challenges which are there to be solved in the context of privacy and security. Then I will also talk about some solutions which have been evolved over a period of time. So at the end of this, each of these actually I will give some time so that audience can ask questions. Okay. So let me start. See, IoT described. The main concept of IoT is the ability to connect loosely defined smart objects. So the first objective of IoT is to connect what we call loosely defined smart objects. By smart object, we mean these objects are capable of doing certain things. That means if you put them in the environment, they will observe the environment. If you put it inside a patient, they will actually measure the parameters of that patient, like blood pressure or heartbeat or sugar and all those things. That's why we call them smart. So once they are connected, they are able to interact with the other objects. For example, if I put a sensor in my field or in my garden, that is capable of connecting it to my mobile device and sending me the information which I want. So that is the first thing, that an object which is smart enough will also be able to talk to another device. And it is also able to interact with the environment. For example, if I put a smart device in my room and if it's actually capable of measuring the temperature, then what it does is also, whenever there is a change in the environment, it would have a system of its own to alert the other part of the system and also to take certain actions. So this is what the second ability of the IoT things. In addition to this, it also is capable of connecting to more complex and legacy computing. What it means is, suppose I have installed some sensors across India, whose job is to collect information regarding weather like temperature, humidity and all. These systems together, many thousands of them, will actually get connected to the central weather forecasting division or office somewhere in India, and they will send this information from them. That means IoT smart devices are capable of talking to each other, plus among themselves with the environment, and thirdly with the large systems. This is basically what IoT is. And IoT to happen, actually it has to have a communication infrastructure. That means suppose a sensor which is placed in my garden, if it has to send information to my place, my office in Bangalore, then there has to be some communication network. So instead of building a new communication network, what people have done is actually they have used the existing internet and they have extended it to other objects. So currently internet actually allows people to connect computers and some mobile devices. That means communication between people and people. Now this internet has been used to extend the connection to other objects also. The reason why we have done this actually, it will enable transparent use of object resources. What it actually means is, see, all these IoT devices need some resources like storage, computational power and all. Since there are models like cloud computing on the internet which will allow you or provide you resources, any IoT device which depends on internet, it will be very transparent in terms of what it consumes and what it actually uses. So because the IoT is capable of smart actions, now we can expect that more and more people, more and more organizations will depend on these smart devices. So these smart devices will densely populate human life. That means you will find more and more of these devices in and around you. Okay, and it also in the human environment. By that we mean actually the places like forest, the places like animal husbandry, the places like transportation vehicle, traffic lines and all. So in every environment you will find them. So in what are these devices are doing? They are providing, processing and delivering any sort of information and command. For example, if you have put sensors or smart devices in your garden, they will tell you about humidity and temperature and other things. Similarly, if you have put them on a patient, they will tell you some information about his health condition. So if you have put it on the very traffic roads and all, they will tell you density of the traffic, the need of the traffic and other things. So they are capable of processing information. That means they can collect information and process that and delivering it to different devices. For example, they can sell this information to transportation commissioner or a traffic police so that he can process. And secondly, objects in the environment will be able to tell us about themselves. For example, if I put a sensor in a particular location, like say in a forest, and I'm using those sensors to study the wildlife there, and they will describe what they are. For example, if I put on one of the tiger or one of the elephant, the smart device is capable of saying that I'm actually installed on a particular animal. And their state, for example, whether it's raining or not in the forest, or whether the particular temperatures something is not like that. And also about surroundings, for example, whether day or night, whether it's the evening or it's afternoon, such things it will tell. So the reason why people will start using IoT is because it helps them to do certain things, like which is told in this particular slide. So the most basic element or most basic device in this context is sensors. So sensor will be integrated into buildings, vehicles and common environments. For example, sensors will be there in the buildings to measure certain things. They will be in the vehicles so that they can understand what is the traffic and they can tell you to the owner or the driver that there is a vehicle in the 10 meters range, or there is a vehicle coming from behind. Can I park this vehicle or not? All this information they will give you. And they will be carried and attached to animals also. For example, I told you if you are a zoologist, some kind of a person or an environmentalist, actually you can also put a smart device on a tagging on an animal and let it on the wildlife so that you can study whether what it is doing throughout 24/7. And the ability of these remote devices or smart devices, they can locally and remotely in order they can communicate. For example, local information also you can get all the information about my college at the center place. At national level also I can get you. So in an IoT enabled environment, sensor is the basic thing which is capable of collecting information, processing it locally and remotely. Now that I have described different IoT scenarios, let me tell you certain examples where it can be used. For example, if you have an IoT enabled environment, assume that you are carrying your mobile device And one of the things that normally happens in any conference meeting is at the beginning of the function, somebody will come and request you that kindly put off your mobiles. So this is a very manual and very awkward procedure. But if you are then in an IoT enabled environment, mobile devices can adopt silent mode when entering a meeting room if it is the request of the meeting moderator. That means there is a device in the meeting room which has been told to convey every incoming participant to switch off his mobile. So that IoT device will actually talk to your mobile device, and your mobile device will automatically go silent mode. So that's one example. So this is one scenario. Second one is, suppose you are using a radio and carrying it in an environment, and if you are crossing a hospital or a medical institution, then because an IoT is installed in that hospital, it will convey to your radio that, see, kindly switch off your radio or reduce your volume because here is a patient, there is a patient care unit. So this is possible because IoT is being installed there. Or it can detect a user when enters a car and connects it to a sound system. Assume that you have a car. Today it is possible that the moment you go to a parking lot, you can press your key and your car will make a beep. Now in the internet, IoT enabled system, it may so happen that as soon as you enter a car, actually it gets connected to your particular mobile, sound system. So this is a third example. Or suppose you have a pet animal with you, and if you have installed some device, some kind of a device on the IoT device, it will help you what your pet is doing at a given moment of time, because that IoT device installed on your pet animal can connect to your mobile device and so on. So these are the certain different examples which are real scenarios. It is also possible at social level, at a higher level. Emergency services could be remotely and automatically altered if fire is detected in a building. So suppose there is a fire in the corner of a hostel, because an IoT device is installed there and it detects there is a variation in the temperature, that makes a decision because there is a high temperature, it will suspect that there is a fire, so it will convey it to central authorities saying that kindly send some fire engines. So these are the higher level applications which can be used. So what does this mean? So what it means, very simple thing. It's such a deep penetration of technology. That means IoT devices going to be installed across the buildings, across the vehicles, across the campuses and all. There will be a deep and very deep penetration of these devices, what we normally call ubiquitous presence of computing. Instead of that, we can say ubiquitous presence of IoT devices. So it will surely pose some security and privacy challenges. What it actually means is, say suppose I am using an IoT device about my pet animal and all. So what are the information that can be conveyed on the network and which will not go to the third party? And security is like, if I have stored some information on the networks or IoT device, what are the challenges? So essentially, in an IoT, security is inseparable from safety. So safety is as good as security. So for example, whether it's intentional or otherwise, suppose you have installed an IoT enabled pacemaker on a heart patient. Okay, you cannot expect it to go wrong, because in that case going wrong means actually causing problem to that patient. So how do I ensure that kind of a security onto that device? Secondly, suppose a car or a nuclear reactor which has enabled, which has installed with an IoT cannot go wrong, because that would threaten the life of an individual, because if an IoT device on which I depend in a car goes wrong, that would end up with an accident which would kill a patient, kill that person. Similarly, an IoT enabled pacemaker, if I don't take enough care, then if it goes wrong, may harm that patient. So IoT security would also mean safety included. Yeah, so now I have described you the basic structure or basic nature of IoT and kind of scenarios, application where it is possible. Now I think this is a time to get questions from you. So, are there any questions?
Not yet, sir.
Any questions, either? Okay. Yes, sir. So I will move on?
Yes, sir.
Okay. So now that I have described the world, now let me go to the next one. That means the first thing I wanted to do today is to describe an IoT world. So that I have done. I will move on. So in order to build an security, I have to have an architecture. I told you any sophisticated mechanism today which needs to be reached to thousands of people or millions of people needs to be very sophisticated. And when you want to build a sophisticated system, you cannot start with this randomly. You have to have an architecture. Similarly, today, in order to build an architecture security, system security into IoT, we start with a system architecture. So look at this. In this picture, you actually find 4 layers. On the left side, you find perceptual layer, which is all about our IoT devices. For example, RFID reader, or a sensor, or a GPS system. So this is the bottommost level. That means IoT world will start with the sensors. Okay. Then we have a network layer, then we have a support layer, and then you have an application layer. So if you remember from your internet layers, there are 7 layers. Okay, called OSI layers, right? So similar, but there actually the bottom layer is actually called physical layer, where actually we have these cables, computers, and so on and so forth. But in IoT, which actually is an extension of internet, we have an additional bottom layer called perceptual layer. It's called perceptual layer because it is where the perception would happen. Perception would mean recognition. So in this, actually there are 4 layers. So look at this. Network layer is the internet layer which we are using. Perception layer is one where actually we are using either an RFID or a sensor or GPS. So this is the building block of any IoT system. There will be a device which gets connected to network. So this is a new one. Network, support, and application layer, they are identical to the layer in the internet. So this perceptual layer, perceptual means it comes from the word perception. The most basic level is the perceptual layer, known also recognition layer, because this is where somebody would recognize there is an IoT, which collects all kinds of information through physical equipment and identifies the physical world. That means sensor may measure a temperature, sensor may measure humidity, sensor may measure the temperature of a patient, sensor may measure the heartbeat of a patient, sensor may measure the humidity in a park. So all this physical information. Okay. And this, to do this, we have some physical devices. There could be RFID reader. For example, if you are in a mall, then the moment actually you have to pass out with an item, or if you are in the library, if you want to borrow a book, they will actually read that scanners. So they are those devices. And all sensors, and GPS also. GPS is also a kind of a sensor which will give you geographical information. The key component of this is a sensor. So sensor is the building block of any IoT system, and this is the most bottom layer. The second layer is actually network layer. That means if I have connected a couple of sensors across my college installed, then in order to collect that information, I have to build a network. So that network layer is the second layer which actually comes. And network layer is responsible for the reliable transmission. That means if I have information collected in my playground or my hostel, it has to come to a central processing unit in my college, whether there is a security office or a principal office. So to do that, I need a network, and that is called the network layer, and whose job is actually to give a real reliable transmission. That means whatever that is collected there in the ground, there in the hostel, there in the temple, there in the library, should reach the destination, whether it could be a security point or a principal. In this layer, the information transmission is relied on several basic networks. So network layer is very common because we have been used to this internet. So there is a transport layer, there is a transmission layer, and so on and so forth. So this could be of anything. For example, if it is a locality like my college, then it could be a LAN. LAN is the network here. Or if it could be, if it is a global one, then it could be including an internet layer or a satellite layer. So the second layer of this architecture is network layer, whose only one job is to reliable transmission of information. The third layer is called support layer. Support layer actually is something like a network transport layer in the internet, whose job is actually to support the all communication. So reliable support. Okay. On this all kind of intelligent computing powers will be organized through network, grid, and cloud computing. So any intelligence has to happen. That means a sensor has collected information, your network layer has transferred it. Now somebody has to use that information to take a decision. That happens on the support layer. And this is actually a layer which goes upward and downward. That means downward, when it goes to the network layer, and upward it goes to an application layer. Application layer is the one which actually is very useful, because what happens to the information which is collected by a sensor in a garden, or what happens to information collected of a patient by a sensor, it is to be used somewhere. And any use of that information is actually called application. The application layer is the topmost in the terminal level. That means there is no layer above that. Application layer provides personalized services according to the needs of the user. So that means if a sensor is installed in a vehicle, then it will give an information which is helpful for a driver. If it is installed on a patient, then it will give information to monitor his health. So if it is installed in a college campus, then it will give information which is needed by a security guard to control. So it is a personal. Users can access and to the internet access through the application layer. For example, you can use your mobile device to get that information, or you can use your television to do that. Any digital device, you can use that. So I have reproduced the picture again to say that there are 4 layers in the Internet of IoT security architecture. Each one will do a particular job. The bottom one about recognition, the second one about reliable communication, support is to support the activities, and fourth one is to application. So any question at this point of time, Sridhar?
Yes, sir. We have many IoT projects to implement. Could you please suggest us some source for funding these projects?
Source, sir?
Yes, sir.
I mean, actually, see, IoT applications, I told you, for example, we are also doing a couple of IoT projects in our college. They are all very basic. For example, there may be a small device which will recognize face, or recognize the temperature and convey it to a network over LAN and all. So any physical activity which you think significant, for example, it could be a traffic control system, or it could be a system which you put at your gate of your college so that it will count the number of people who enter. So this can be done actually. But if you have a very specific request to make, actually you can send me an email, then I can answer it in details. But one of the best thing about IoT is actually you can start using in your context. It is not like other technologies where you don't see something happening in your context. So as in a very application which is as small as which can be completed in a day can also be done using an IoT, or it could be as complicated as a traffic system.
Please show the slide with the architecture.
Yes, sir?
Please show the slide with the architecture.
Yeah, this one. Look at this, sir. I am showing now.
Okay, sir.
Any question on this?
No, sir, they just want to see it again.
Oh, you see it actually. Okay. Yeah. Shall I move on or?
Yes, sir. Yes, sir. Carry on.
Okay. So now that I have identified the layers, now I should find out the challenges which are there, which are going to stop me providing correct security or required security. So let me recognize the challenges. So the challenges in the first layer, that is perceptual layer, is recognized like this. Usually perceptual nodes are short of computer power and storage capacity because they are simple and less power. For example, if you have installed a sensor, it is not a complete computer. It is a digital device, but it is not a complete computer. It doesn't have an extra processing power, nor it has any additional storage space because it has been designed that way. And if you remember, the difference between an embedded system and a computer system, regular computer system, is that embedded systems have been designed in such a fashion that they don't have any extra powers because they have been designed for a particular job. So in order to build a security system at perceptual level, one of the challenges that you face is these devices do not have additional power either in terms of storage or processing. So you have to do something to do that. Therefore, it is unable to apply frequency hopping public key encryption. You know, any encryption system needs a lot of power because it has to convert whatever you text into a ciphertext, and that it has to go through the network. So you cannot apply these schemes at sensor level because they don't have that power to convert whatever the data collected in converting into ciphertext. So this is the first challenge. Secondly, any denial of service, for example, suppose there is a network traffic in such that actually a request from the sensor is actually denied because there was an unreliable agent who is making many calls to the server, that can also has to be taken care. So what do you remember from this level? This one is at the bottom we have sensors. They are not capable of having additional resources. Then the traditional services, we cannot use them as a security mechanism because lack of power. The second layer is actually the core layer, has relatively completely safety protection ability. So we know this network layer, this is one of the layer actually where every security mechanism is worked out, because now any communication that starts from a machine today on the internet actually is encrypted. And we also have all the websites now that saying that HTTPS, that means it is almost now regular routine that everybody will use a secure channels for any communication. So that is not a problem. But the problem of man in the middle, for example, suppose you are collecting the information from the sensor and you are sending it to a machine. What is the guarantee that the sensor only is sending the information. Somebody may be collecting that information in the network from the sensor and diverting another, additional information to the server or this one. So this is, this is traditionally called a man in the middle. So that is also be taken care. What it actually practically means that if I have installed a sensor in my garden, okay, what is the guarantee that only sensor is sending the information which it has collected, or somebody has intervened in that process and sent the information of his or her choice. Okay. Secondly, since it's a network layer and if thousands of sensors are sending the information, then there is a question of this congestion also, because network layer is not only used by sensors, other devices like computers, mobiles are also using. So in the second layer I have two problems. That means how do I identify or I ensure that there is no middleman in the information communicated, and how do I ensure that there is no network congestion. And the third layer is actually used for, I told you, a lot of data processing. So intelligent decision have to be made. So now the question comes is actually whenever a lot of information decision is making, then we have this kind of like viruses, okay, malicious information, additional information, junk mails and all. So this will be a problem in support layer. That means since it involves lot many data processing, it is possible that you don't only get the data that you need, because somebody will be pushing data either for a marketing purpose or for the condition purpose or the nice purpose and all. So that means your network layer, a support layer system must be capable of recognizing the correct information and avoiding the malicious information, whether intended to mislead you or intended to delay your processing or intended to congest your problem. And in the third, in the fourth layer, in this level, security needs for different applications are different. For example, suppose you have a very simple application in which you collect information and make a decision about whether to water your garden today or not, then that kind of security is not high, because after all you are involved with plants and all, you don't run a risk of life and all. But suppose you are collecting information from a patient and you want to apply your prescription and all, then you need a different kind of security mechanism. What it means is, in an application layer, different application needs different security levels. And secondly, data sharing is one that characterizes our application layer. For example, the data should be shared with a doctor, they should be shared with a pharmacist and all. Now, how do you ensure that security happens? That's the second question. And third is access controller and disclosure of information. Suppose you have stored some information which is collected from the sensor, that how do you ensure that only reliable people will collect it? For example, if I have been collecting information about the student movements in the college, then it should be seen only by the authorized people like principal or security people. It should be seen by a classmate, right? So that kind of a access control must be built up. And disclosure of information, what is collected and what is disclosed to the public. So now I have described you the challenges which are there in the four layers, starting from perceptual layer to the application layer. So now that I have described the challenges, now I will list the requirement. Now that I know my problem, what are the requirements? So what is the ideal system which would solve my problem? So look at that. At the perceptual layer, that is the bottom layer, I need lightweight encryption technology. I cannot use this PKI or other systems which are very power hungry. That means they need a lot of processing power and also electrical power. I need lightweight. So what is the requirement? At the bottom level is, and protecting sensor data. That means sensor data, whatever that I collect, should be collected without any intervention. For example, somebody should not put a misleading data into my sensor. The third one is key agreement. That means when the sensor, the end device sends information to the another layer, network layer, then there should be a kind of a handshake, and then the collection of information should they should be transferred. In the network layer, I want identity authentication. That means suppose there is a device, then I should know that this device is installed in this particular hostel in my college. It should be an authorized device. And encryption mechanism, that is obviously, and communication security. So it is one thing that I put my sensor very secure. But what would happen to my data once I put into the network? Then what happens? It starts from my college and goes to the head office. In the communication on the path, it should not be like, it should not be changed or it should be meddled with. So that was communication. Okay. Okay. And support layer, I need multi-party computation. That means actually what happens in this IoT or in internet actually, it is not a communication between two people, it is communication between couple of people. For example, suppose I am purchasing a book on online, then I have to communicate with the online vendor. Then when I want to share my address for a courier company, then I have to share that information with somebody else. And if I want to make an online payment, actually I have to communicate with my bank. So such a communication is also called multi-user communication or multi-channel communication. So how do I ensure that my data goes to a particular service provider safely, and from that he will exchange that information correctly with others. In the application layer, authentication. That means if you are a Gmail user, you only have to log in. So these are the basic requirements. Let me describe in detail. At first node, authentication is necessary to prevent illegal node access. That means if I install the sensor, it should be authenticated. It should be an officially given sensor. Today, sensors are very cheaply available. Unlike computers, which will cost you a lot, people will not replace a computer. But suppose you install a sensor in the college balcony or just in a particular location in a college, people can buy another sensor and replace it and divert all the collected data. So that kind of authentication is to be there. That means every sensor which is put in must be authenticated, which is it will be secure. Secondly, they protect the confidentiality of the information transmission between the nodes. Data encryption is absolutely necessary. Whatever the information is collected from the sensor should not be sent in a native or a raw format. It should be converted into a ciphertext and should be sent. So in the level number 1, the first one is every sensor must be authenticated, and second, the data must be encrypted. And data encryption key agreement is an important process in advance. The stronger the measures, the more is the consumption of resources. To solve this problem, lightweight encryption. I told you, you cannot have a regular encryption models in the sensors because they lack that power. In the network level, identification is a kind of a mechanism to prevent illegal nodes. That means, suppose I have installed 100 sensors in my college. What if somebody installs another 10 without I knowing that? I means the college authorities knowing that. So that means each only authorized node or a sensor should be part of that. And for that, you have to have identity authentication. It is like, say, giving identity card to each student. So any stranger or any newcomer will be identified very easily. And at network level, layer 2, you also have to take care of denial of service. That means if there is too much of congestion, unauthorized people are trying to access resources, that would create a kind of denial of service that should also be taken care. And in the support layer, needs a lot of application security architecture. That means now the application would come here. So what you have to do is actually each application should be assigned to a user. Only he can use that. For example, if there is an application which uses the sensor data collected in the college, only security people or the authorized people has to use that. And secure multiple computation. I told you many a times it involves couple of individuals or resource people or vendors that should be taken care. The details I will tell you later. Application level, to solve these security problems, we need users privacy protection. That means if you are using a sensor collected information for a medical application, then user must be aware of what is happening to his data. Suppose you collect some private information regarding his health or income or his body weight and all, you should ensure that it reaches only a doctor who is authorized to see that, and it doesn't end up with a person who is interested curiously about that person. So the summary is that there are challenges in each one of this and there are requirements in each one of this. In summary, security technology in the IoT is very important and is full of challenges. We identify the challenges, we also identify the requirement. On the other hand, laws and regulations are also very significant. See, the security in IoT is not just a technical issue. It is not an engineering issue. It's also a social issue because it involves people, and when people are involved, there is a society, and when there is a society, then there are governments, and when there are governments, there are rules and regulations. So all this will come. So it means the security issues is a techno-legal issue. That means techno, and it's also techno-commercial because many companies will use IoT to run businesses. So that time, what happens to customer rights? What happens to consumer information? That also are big questions. So now that I have described, let me tell you certain examples which will illustrate or highlight these security problems. In a factory floor automation, suppose you are using IoT to establish a factory automation, the deeply embedded programmable logic systems that operate robotic systems are typically integrated with enterprise IT infrastructure. That means they have connected because there are ERP systems, there are other kind of systems. How can those PLCs be shielded from human interferences? For example, suppose you install an IoT in a factory floor and that itself is connected to your IT resource like a main computer and all. How do you ensure that somebody will not use that sensor to reach your main server? Okay, and yeah, that's the first question. And second is control system for nuclear reactors are attached to infrastructure, because suppose there is a Trombay or any nuclear center, then they will use some IoT devices for monitoring. And these IoT devices, by definition, they are outside the premises. Okay, then how do you ensure that somebody will not actually touch them? They will meddle them and they will control them so that they will use that as a door to enter your central systems. Thirdly, an example which is very important from the individual perspective. Suppose that you have a smart meter. Smart meter is like our electrical meter, which is used to measure the consumption of electricity in a home. So depending on your requirement, the service provider will be monitoring you, so that depending on your usage pattern, they will be offering certain concession. For example, if you are using more than 20 units a day, then he says your charges will be some 10 rupees per unit. Suppose you start using 40 units, maybe he will offer 8.5 rupees. This must be able to protect information from the unauthorized. For example, if the information is collected by the service provider, then what happens is actually, suppose I'm living in a house and we are only 2 people, and suppose I go out of my home for a vacation. Then what happens is my company, because I am using a smart meter, will notice that there is a dip in the electrical consumption. That means for last 10 days there is no electricity. If this information go to somebody who is a thief, then he will come to know that this house is empty because there is no consumption of electricity for the last 10 days. That might lead into kind of a burglary, or if it is old age people are living in that could lead to certain kind of other problems also. So now I have described you the challenges and also different scenarios. Any questions, Sridhar?
No, sir.
No, sir. I'll proceed.
Yes, sir.
Okay. So finally, I will talk about the features of this system. So any security system and privacy system should have its following qualities. Resilience to attacks. That means if there is an attack, the system should be in a position to withstand that attack and come back to normal as soon as possible. So resilience is a feature which can be illustrated with the following example. Suppose you drop a stone, it will not bump back or it will not bounce back. But if you drop a ball, it will bounce back. The reason is ball has a resilience quality. That means it will actually take all the thrust given by the land or the ground and it comes back. Similarly, any network should have this quality. That means whether it's IoT or internet, if there is an attack on one of the nodes or one of the part of that one, it should not break down and stop working. It should take that attack, somehow mitigate that and come back. So that's the first quality of any IoT or internet network. Secondly, data authentication. That means you must always know that the data which is given is correct, authorized by somebody people and signified by some people. Access control. If there are data storage on the networks, whether it's a sensor data and all, only authorized people should use that. And finally, client privacy. Suppose some patient or some student or some system has been using sensors. That data, if it belongs to a particular person or an institution, that client should always have a privacy. So this is what resilience means. It should avoid single point failure and adjust itself to node failures. That means, for example, suppose I am using a computer today. Then if I have directly connected to the electrical power, then if the power goes, my system will go down. So that means there is a single point of failure. But suppose I am using an UPS system, then even the power goes, I can run my system for next 10 minutes. That means I have one layer of defense which will ensure that even the power goes, my system is on. Similarly, networks must have some kind of a mechanism which in turn will ensure that if some level problem happens at level, it will be limited only to that and it will not perpetuate or it will not go further down. Data authentication, as a rule, retrieved address and object information must be authenticated. That means if some sensor says that I am so and so, I am installed here, that must be verified and authenticated. Access control, you know, this is something which we know in other internet application also. If it's your Gmail account, only you must be able to access it. If it's your bank account, only you must be allowed to check that one. Client privacy is something which is a very big important. Many times we hear the stories like somebody has downloaded thousands of pictures of celebrities which are stored on their Apple accounts or Gmail account. So what we mean by client privacy is a process where actually the information stored by an individual or an institution, if it is of a private nature or personal nature, that should be maintained. That means it should not go to the public hands. Any question at this point of time?
No, sir.
Any questions? I'll proceed?
Yes, sir.
Okay. So finally, I will talk about the solutions which are there for this one, this infrastructure architecture. We all know that no one single system is going to adequately protect the device in an IT environment. See, in fact, one of the nature of this IoT is like unlike the regular computers that we have internet, because only computers can be connected to internet. Whereas in IoT, any device can be connected. It could be a sensor, it could be a smartwatch, or it could be a smart TV, or it could be a smart fridge and all. So one system will not help you. Okay. Hence, a multi-layered approach security starts at the beginning. Okay. That means it should start at the beginning when power is applied. So if you are installing a machine or an IoT device, the first level of action for security is as soon as the power is installed, somebody should ensure that only authorized person is powering it off, and whatever it gets loaded during that process is authenticated. Establish a trusted computing. That means only authorized people will boot that system and ensure that one. Anchors that trust in something that cannot be tampered with. You should ensure that their sensors or any smart device which is installed is not being meddled by a third party. In order to do that, we will be doing secure booting. See, unlike the computer booting where actually anybody can boot, but somebody cannot log in, secure booting is a process where only authorized agents or people can boot a system or a sensor. Access control, nobody can actually modify the settings of that. Device authentication, nobody can replace an existing device with another device. For example, they cannot remove an existing sensor and put another sensor. Firewalling and IPS, updates and patches. If there is a change in the software which is installed on these sensors, is it possible that whenever you want to update, that is actually regularly done or officially done? Secure booting is the one where actually you can read it. When power is first introduced to the device, the authenticity and integrity of the software on the device is verified using cryptographically generated digital signature. That means only authorized software can be installed on those sensors. The digital signature attached to the software image and verified by the devices ensure that only the software that has been authorized to run on that device. For example, if you are using a sensor in a park or a private public place, or if you are using a sensor in a security where actually it's a bank, those are two different applications and those need different software. So you should ensure that only the software which is needed for maintaining a park is installed on a sensor which is installed in a park. Similarly, the application which is needed to run a bank system, that should be installed on that sensor. So that you should take care. The foundation of the trust has been established. That means now you know that it is officially and authentically it is booted and the regular system and software has been installed that way. Access control, this is role-based control. This is something which is also true for any internet-based system. Role-based means if there is an information system, there are certain privileges which a doctor will get. There are certain privileges which a patient will get. There are some privileges which a nurse will get, and there are certain roles that a paramedical will get, and there are certain information only a pharmacist will get. So this is called role-based. Similarly, if there is an information system in a college, there are some information which principal will get, and the HOD will get, a student will get. Device authentication, when device is plugged into a network, it should authenticate itself prior to receiving transmitting data. This we all know that whenever you enter a wireless or wireless environment, in order to get connected to that, you have to identify yourself. So normally a MAC number is used in case of computers. Similarly, each device, each sensor must be identified. Firewalling is something which is very common, not necessarily only for IoT, this is for all systems. Updates and patches. If there is a change in the software which is installed on these thousands of sensors, you should ensure that only authorized people and authorized versions of this software is installed on them. So any questions? These are the solutions which are there for ensuring IoT devices. Any questions either?
What do you mean by education security in application layer?
What is that?
What do you mean by education security in application layer?
Education security?
Yes, sir.
Where is that? Is there in my slide?
That is what the question is. Maybe they can clarify. How can you provide security for sensors not accessible to others? Are there some standards in this regard?
Yes, see, the industry is developing some kind of a mechanisms actually. Now sensors, see, what we get in the market were very cheap kind of a thing. Means what by cheap is very less expensive. They don't have that kind of a features. But whereas actually now they are building some sensors which have a standard mechanism for authentication. See, for example, today if I lose my mobile, or if somebody removes my SIM and places another SIM, there is an automatic alert will come to a police station, or if you give a complaint. So now what actually happens in those mobiles, there are mechanisms which will ensure that if somebody removes the existing SIM, both its location and the insertion of a new SIM can be identified. Similarly, in sensors today, if somebody tries to replace an existing SIM sensor, or if you want to remove that, an alert will be sent to the owner of that installation, and you will get an alert, say somebody is trying to touch your camera, which is smart, touch your sensor, which is installed in a park. Yeah, that mechanism standards are available, sir.
How man-in-middle attack can be prevented?
Well, actually, that's what I'm telling you. See, if you have installed just a sensor, it is possible that somebody will feed his information to sensor and will send it back to the network. This kind of an attack is called man in the middle. Or it is possible that somebody would divert the collected information from a sensor to another point, and he will stop that information and send his information. So this is possible because you are sending the data in a very native format and in a text format. So if you want to avoid this one, all you have to do is actually you have to have an authentication. That means access to the sensor, and also the information collected by sensor is protected using an encrypted mechanism. That's number one. Secondly, you ensure that the information which is leaving a sensor will go to a particular destination, and that is a pre-programmed one. That means a sensor which is installed in my hostel will send information only to my central system, like which is installed in a security. It is not allowed to be diverted elsewhere. So you programmatically you can limit that one.
How can we implement cloud with IoT?
No, actually the thing is like this. See, IoT is a phenomenon which can be enabled by cloud computing, because IoT at some level need processing and storage powers, right? Okay, so suppose you are installing an IoT system which is very broad in nature. For example, if you are installing a traffic control system for a couple of towns or couple of cities, then you need a system which is supported by cloud computing, because it needs a lot of power. But another aspect of IoT is also many times IoTs are local in nature. For example, in a smartphone or in a smart home, there are many smart devices which will talk to each other. A fridge will talk to your cell, or your cell will talk to your TV and all. In such cases, using cloud computing is actually waste of everything, because every time you store data, it has to go to cloud and come back. So now there is another mechanism or another approach called fog computing, or it's also called network edge computing, where actually if information is needed locally, then it is possible that you collect all the information and keep it at the end of the network. Don't send it to cloud computing. So depending on the application, for example, it's a smart smart campus, college campus, or smartphone, smart home, then you don't need cloud computing. But if it is a city-wide or a state-wide kind of a thing, then you need cloud computing. And which one to use, then it depends on the category that you are applying. Cloud computing is an enabler in this, provided its application base is big enough. Any questions, sir?
No, sir, not yet. We will just wait for 1 more minute and see, sir.
Yes, yes, yes.
Only computer science experts can build IoT, or anybody assemble with the help of programs through net or other help?
Yes, see, the beauty of IoT is that it is actually intersection of 3 different disciplines. Computer science people will give the algorithmic approach, programs and other things, whereas the IoT in electrical and ENC people give you the devices. For example, sensor is not designed by a computer science person. It has to be, it's a physical device, it's a hardware which is designed by an electrical person. Okay. And the third one is this communication part. So that means even a person who is good in networks, they also need. So IoT is a phenomenon which is actually a combination of 3 things. Computers, because you need programming, and ANC people, electrical people, you need devices. It also part of like automotive design, where actually mechanical engineers also participate. And the network people who actually will help you communicate between different. So it's an interdisciplinary, which is actually a combination of electrical, computer science, mechanical and network. And it's a good feature about that.
That's all the questions, I think, sir. Some of the participants saying thank you to you.
Okay, I'll pass it on. Okay, sir.
Yes, sir.
So that's what. This is the summary, and I will move on. So the conclusion is privacy and security are essential features of a modern network, and IoT is a new modern network. Internet sense is no exception. So unless you build enough and robust mechanism for building security and privacy, nobody will start using IoT. Industry has built different security approaches to ensure that security and privacy. Though in IoT itself is growing in large number, the fundamental blocks and fundamental measures of security and privacy have been already built. Okay, but let me add one more thing and finish the thing. Okay. See, in today's network, it is not communication between I and you. That means there are not 2 users involved. There are a couple of people are involved. For example, when I do a transaction on a bank, when booking a ticket from Indian Railways, Railways is one party, bank is another party, I myself is another third party. And suppose I am booking another taxi along with there is a 4th party. So such kind of a thing is called secure multi-party computation. That means my information goes to Railways first, from there it goes to the banking, and from bank it comes back to a third party. So the Internet of Things will create tremendous opportunity to improve life. The core property of most ubiquitous communication is the ability to perform joint cooperative tasks. That means I want to book a ticket, my bank and railway should cooperate. Okay. If I want to book a taxi, then my bank and my cab operator should cooperate. So now these computations are performed by mutually untrusting parties. For example, I don't trust my bank, bank will not trust Indian Railways, Indian Railways will not trust the cab operator. So now it has to be done. So one of the challenge in this IoT is actually how do you conduct this kind of a computation in a trustworthy manner when different people are involved in that. Okay. So secure multi-party communication may become a relevant and practical approach that should be considered as a technological means of protection of the user privacy. So I share information with Indian Railways. How do I ensure that they don't share with a bank? Or I send my credit information with bank, and how do I ensure that Indian Railways will not get? So this is going to be a challenge. Secure multi-party computation is also known as SMC, is actually one of the fundamental area where a lot of research and application opportunities are there. So industry has already developed certain technologies which will ensure that an individual is protected from many of the kinds. So it's called virtual private networks, transport layer security protocols, DNS security, onion routing is one technology, and private information retrieval, where actually authorized person can only retrieve it. Okay, so the conclusion is this: IoT security design should enable an open, pervasive, and interoperable yet secure infrastructure. So if you expect the whole population, whole world has to use IoT, first it has to build security and privacy. But while building this, it should be open. That means it should be able to be used by different vendors, different devices. And it should be pervasive. You should not say like this will work only in this particular operating system. It will work on this environment. That should not be there. And interoperable. That means it should be working on my laptop as well as it will be working on mobile, or it should be working on a desktop, or it should be working on my fridge. Okay. For the sake of privacy and flexibility, IoT, a smart device, must be capable of implementing individual user set policies. That means the liberty should be given to each participating device, like sensor, to set up its policies, that I want to talk to this device, not to this device. I want to share only this information, this particular device. This kind of a freedom and a liberty should be given. It is like setting your own, because in Gmail you have a setting, account setting, that kind of a thing. Infrastructure security services should be accessible to transparently. That means what are my security settings, what each device is collecting from my device, or where is my information going. That should be there. It's like say browsing history. Okay. Since devices have become nomadic means now you may be using your device today here, tomorrow elsewhere. So now every system that you come across should be capable of providing this particular feature to you. Okay. So if anybody is interested in the references, these are the different references that I used for preparing this presentation. So end of this session. So I have completed the previous session. My next session would be on applications of IoT. Now that I have told you what is IoT, I have told you in a web architecture for IoT, and I also consider the security and privacy in this particular session. The next thing is how do I develop applications on the IoT? That will be this theme of my next session. Okay. So if you want to contact me for whatever the reason, this is my website and this is my email ID, and you can see all my presentation, recorded presentations on YouTube somewhere here. So any more questions? Otherwise, I have come to the conclusion, end of my presentation. Sir.
How do different devices having different semantics communicate?
Okay, see now what is actually happening is there are machine-to-machine communication and device-to-device communication. So now what they have done is actually, when they want to make semantic thing, then there is a kind of an interpreter. For example, we know that we have compilers and we also have programming languages. How will a native end processor will understand your code? Somebody will translate that to compiler to assembly code, and eventually it gets executed. Similarly, when device-to-device communication is to happen, there will be what is known as middle layers between these devices. So what happens is, suppose a mobile is talking to a sensor device, then there is a software which will sit in between them and says, now actually I am getting information from a mobile and this should go to a sensor. So either upward or downward translation would happen, and that would reach the end device. And probably you know that I showed you something called support layer. Support layer job is to communicate between your application layer and the down layer, that is the down layer. So this is where actually the middleware will sit. So it sees that this application is running on this particular device and this speaks this particular language. But my user is actually using this device and he is sending this information. So somebody will sit, and that's called middleware, which will translate both syntactically and semantically between the devices.
You may know about services like thingspeak.com. How do you compare it with service from Amazon, Nimbit, IoT from Microsoft?
See what happened is actually, IoT is a big phenomenon and every leading company is actually coming to play a role on that. It is like, say, in 10 years, I mean 10 or 15 years back, when people started to realize that internet is important, every company started releasing its own browser. Okay, Microsoft has Internet Explorer, Google has what is that? Their own browser, and Firefox and so on. So similarly, all these companies also trying to build in their own platform for the implementation of IoT. So, for example, Microsoft has, I think, Azure extension, and Amazon has Kinetics, and Google has Push Pop, something like that kind of a thing. Okay, so these are all the different platforms which people are trying to push into the market, so that more and more people, customers will come to that. But eventually what would happen is, like, say, depending on the openness of that systems and the interoperable feature, there will be a kind of like a conclusion where one or the other system will become very famous. For example, today Microsoft Internet Explorer nobody is using, or at least company itself has stopped doing. So all these companies have been trying to put their systems into, systems for the public domain for the consumption and to build application. Let us see who will decide, who will actually win. But these are different applications, platform for developing IoT and connecting them to the systems.
In Economic Times newspaper last week, a big scenario like billions of dollars being invested in this IoT was predicted by 2019. There is an urgent need for teaching our students the basic principles. What would you prescribe for a course?
Okay, see, actually you can connect me to, for example, I am introducing a course on Internet of Things for my students starting this June semester. Okay, see, when cloud computing came back in 2010, I was one of the faculty to introduce the cloud computing for the first time somewhere in our university or at South India. Similarly, I'm introducing an IoT course in this coming semester. It will start in the month of August. It's a semester-long course, a semester-long for the computer science and other engineers, also mechanical and other engineers. So you can send an email to me. I can share the syllabus that I have designed. And moreover, actually, the Indian government also has come up with a draft policy which is encouraging the institutions to introduce IoT at BTech level and MTech level. So if you are interested, you can get connected to me. I will share you the syllabus with that. And what I should also tell you is, actually, IoT also we have been hearing for a very recent times. It is a very well-known subject within the academics. There are institutions which offer engineering course of 4-year engineering course in IoT in some of the countries. So any details you want, at least the course that I am going to introduce, I can share with you. I have already established a website for that. I can share with that person.
Yes, that's all the questions. Thank you, sir.
Thank you, sir. Thank you. Thank you for the audience. Thank you very much. Bye.
Thank you.